So we have the streams of information, and by using this efficiently, the input and output of the programs are handled in the Java programming. So there are two different streams that are available. The first one is all about binary streams, and second one is nothing but a character streams. Then we are writing a class that is file write demo followed by public stat void main. So this is a main method that we are creating with a throw IO exception. Hello everyone, I welcome you all to the first session of Unit 4. Unit 4 is all about file handling, and this is, as we know, it is a second sem subject which is none other than object-oriented programming with Java. So let's move forward and see the agenda of today's session. So in today's session, we will be discussing regarding file, like how to handle a file, introduction to file handling, then IO handling in Java. Then we will also be discussing stream, then the types of file streams that's available in Java programming. Up next, we will also be discussing byte stream, then byte stream classes, as well as the hierarchy of it, then followed by file input stream class and example. So similarly, we will also be discussing file output stream class along with the example, then binary IO classes and object IO classes, followed by the object input stream as well as object output stream. And later we will also be discussing the advantages of file handling. So this is the agenda of today's session. Let's start our session with understanding the introduction of file handling. So in this figure, we can see it is a Java file handling, and here we can say that the files can be permanently stored through file handling. So we can see here the file is been undergoing storage operation. So this is allowed by the file handling. We can also observe the data or the information that is available inside that file can be made available even after the termination of the program. So let's consider we were executing this program and we are done with that execution, and that executed program can be made available through this file handling technique. So this is all about file handling in Java, which allows a user to store that file and make it available even after the execution of the programs. Moreover, the Java provides or it supports a complete IO classes by using the package. So that is none other than java.io. So by using this package, this Java programming allows or allocates the various IO classes that is required under program. Alright, now let's see why exactly this file handling is essential for. Yes, definitely this is essential to store our data. Then it is also used to store the logging information. Then the various configuration files related to other programming languages can also be stored, and even the Java programming language configuration files can also be stored and handled efficiently by using this file handling techniques. Then further, it can also be used for object persistences also. Up next, let's see how this IO is handled in Java programming language. We can say that the Java IO is exactly handled by using streams. So we have the streams of information, and by using this efficiently, the input and output of the programs are handled in the Java programming. As we know, input in the sense reading the information from a source, and output in the sense writing the data into the destination. And this combination of source and destinations are included with keyboard, then file handling, followed by network and the memory. So these are the things where we go with input-output operations. All right, let's move forward with understanding what is a stream. As we did understood, the complete IO class is considered with an stream in Java, right? So now let's move ahead and understand what exactly this stream is. A stream is nothing but a sequence of data. The Java treats each and every IO operations as a complete class based or a complete stream based classes. The main thing to note here is the streams are completely unidirectional. It means, like, if you consider input stream, then it is completely utilized to read the data, and the output stream, it is completely utilized to write the data into the destination. So over here we can see the information or the stream, how it is. So this forms a set of stream that is considered under Java, which says that it is a sequence of data. So this is all about a stream. Now, as we did understood a simple stream, let's move forward with understanding the types of streams that is available in Java programming. So there are two different streams that are available. The first one is all about binary streams, and second one is nothing but a character streams. Binary stream, as the name itself says, it is used to represent the binary data. For example, our information, or we can say the files, image files, the video files, audio files, all are converted into byte and they will be stored in a file. These are the various examples which can be included under the byte stream. And the main thing to note here is, yes, exactly, it is the class ends with input stream if it is an input, and output stream if it is an output. We will not consider it as input output. We will consider it as an input stream and a output stream. All right, the next character stream, as the name itself says, it is used to read the text data. So the textual data, transactions or the operations are handled by this character streams, and at the input and the output, the classes will exist not in the form of input output, but instead in the form of a reader or a writer as we deal with the characters. All right, so we can see here we have a character stream and a byte stream example. So byte stream in the sense any specific symbol converted into the form of binary values. All right, so this is all about the types of streams that is available in Java programming. Now, let's understand the types of files that is handled by Java, or the types of files that is supported with Java programming. So yes, definitely the first one is none other than a simple text file, and the second one are binary files. Under text files, we can assure that the data are none other than the characters or a set of characters. We can also assure that these characters will be in the form of human readable format. So the formats that are considered under the text file are none other than .text and .java. So these files are in a form of human readable forms, or we can also say these are written in a characters. The next type of file is none other than a simple binary file. Here, as the name itself says, our data will be stored in a form of a binary value, and it is not at all feasible to read by a human. It is not in a human understandable forms. Okay, so the example is .class.exe. .exe, it is completely an executable file which must and should has to be converted to binary, because it has to be understood by the IDE and then the program will show the output, isn't it? So these are the various formats, that is none other than .dat, .class followed by .exe. So these are various types of files that are available. Now let's understand a bit depth away. So that is with respect to byte streams. So we have discussed this in a glimpse way, correct? So now let's move forward and understand in a more descriptive way. All right, the byte stream, it is capable of handling 8-bit binary data. Then these byte streams are utilized whenever we are dealing with audio, image, video, as well as various executable files. So if you want to make your audio, video files as a executable files, or these files must be handled by a system, then you have to go forward with the byte stream only, because that is the only option which is available. All right, now let's see what are the various key classes that is been included in order to store this. So we will be utilizing input stream and output stream. So input stream is used to read the data, right? Similarly, output stream is used to write the data into the destination. So this read and write operations will happen in a byte forms. When we did understood that these input stream and output stream are required, so there will be some hierarchy that we have to follow, or a user has to follow. So let's move with it and understand that hierarchy of byte stream classes. The hierarchy with respect to input byte stream is, the first priority will be given to a simple file input stream. Nextly, it will be provided with the buffered input stream, and later for object input stream. Yes, initially it will be, the priority will be provided for a file, then followed by the buffered input stream, and then comes a object input stream. So it's the same thing with respect to output. Initially file output will be considered, later buffered output, and at last the object output stream will be considered. So this is the hierarchy that has to be followed. So this is the thing that is must and should be followed whenever we go with operating the byte streams. So over here we have a simple representation of byte stream. So initially we know that through a program we will be having the input. So that input will be converted into the byte form, okay, and that byte form will be transformed to a destination, and this process is carried along with a stream, that is a sequence of data. Correct, right? So this is a sequence of data, first sequence, second sequence, and this data will be reaching the destination. So this is all about the hierarchy of byte stream classes. We did understood bit by bit, like what is a stream, then what is stream class, what is the types, then the hierarchy. Now let's start understanding the file input stream as well as file output stream through a example and along with the representation too. So let's start with file input stream class. This class is usually referred or utilized to read the data from the file. And how this reading operation happens? It happens byte by byte. And the main thing to note here is this class will be belonging to the package. So which is the package? That is none other than Java IO. So this package will support the file input stream class. So let's see a representation of this. Over here we can see that we are utilizing the keyboard, that is none other than system, to input the data. So this data will be transformed in the form of byte by byte. So over here we can observe the data will be read from the keyboard byte by byte, and then it is following the output stream path. It will follow the output stream path and reach the text file .txt file. So whatever the data you are inputting, it will be stored in a text file. So here we can see that we are creating a text file, that's by utilizing the stream class. It is none other than file input stream class. So this is a complete representation. All right, let's move forward. But before that, let's see a simple constructor syntax that is been defined here. We are defining file input stream, that is the file name first, which will be equal to new file input stream of. So this data.txt is the new file that is being generated. Thus, the file input stream present file will be read into the data.txt file. So this is a constructor class syntax that can be considered to define the input file stream class. All right, let's see an example over here. As we know, the initial thing that we have to do is we have to include the java.io package, right? So that's our initial thing, that is import java.io. Okay, that's done. Then we are up with creation of the class file, that is class file demo. Okay, then we are representing the main method. Through this main method, we are throwing an exception, that is throw exception, followed by file input stream, then the file name. So the file name that we have considered initially is first, but we are creating a new file with a name sample.txt through this constructor. All right, once it is done, we are defining a integer character followed by a while loop in order to read the file, and the process has to carry out until the byte stream becomes equal to -1, then followed by a print statement of system.out.print, that is for displaying the character. Let's close the bracket. So up next we need to close the file that we have initiated, that is FIS. Then close the loops. Once the execution is completed, At the output, we will be getting this sentence which says that contents of sample.txt is displayed on the screen. And along with this, we will be getting a text file displayed. Great. Up next, let's move with file output stream class. As usual, this is completely used to write the data into the file, and even here the data is written in a byte by byte form. It won't go in a one go. Byte by byte, the data is transformed into the file or the destination. And if in case the file is not there, then the file will be created automatically by this class itself. Over here, we have a constructor that is file output stream, FOS. That is file output stream. That is our initial name of the file, and we are creating a new file with a name that is new file output stream, and the name for that new file that we have considered is output.txt. So this is a simple constructor example. Now let's see the representation. Here we know that the writing format will happen. So in order to write, the data will be picked from a .txt file. The data will be picked from a .txt file and it is transferred byte by byte. So where is it transferred to? It is transferred to some destination file. Let's consider if file is not there, then it automatically create a file and the input, whatever it has been extracted, will be written into that file. So this is a complete process of reading a data from a text file. So this representation is very, very important. Please try to write with the pictorial representation too. Let's see an example over here. So we are importing java.io. Why? Because this file output stream is included in the package. So which package? That is none other than java.io. So we need to import that package. Done. Then we are writing a class that is file write demo followed by public stat void main. So this is a main method that we are creating with a throw IO exception. Okay. Followed by we are writing a constructor that is file output stream. The initial name of file will be FOS followed by a new file that is created to write into the destination is none other than output.txt. So this is constructed followed by the string message we will be including like welcome to Java file handling. Further, we are writing a method that is FOS.write of message.getBytes. What does this show? It shows that information is transferred byte by byte. Up next, once the operation is done, we need to close the file. Then we are writing a print statement that data written successfully. Let's complete the loops, then followed by after execution of this program at the output we will be getting that the data are written successfully, which means that the complete information that is present in our main data file will be written into the destination file. Alright, let's head up with the next topic that is none other than binary IO classes. These are used to store the raw binary data, which makes more easier to handle the complex data, and in turn the efficiency as well as the performance of the system can be improved. So let's see the importance of this binary classes here. The binary classes are used with the buffered input stream, buffered output stream, and also it is used along object input stream and the object output stream classes. Now let's understand what does a object IO in Java meant. Object, as we know, it is a real-time entity, right? So this Java programming is completely dependent on object-oriented programming language. So this object is very, very important, and the operations with respect to object, that is input output, will be crucial. Thus we can say that the Java IO allows the reading and writing of object. And how these objects are implemented? It is completely implemented through serially. Okay, it will not be transferred completely. The data will be transferred serially. Thus, let's understand where exactly this binary IO is utilized. So, it is used in order to save the application state, followed by to maintain the object persistencies. Great. Now let's move forward. First one is object output stream example. Again here we are importing a Java IO package followed by defining the class, that is student implement serially. So for this we are going with declaring a integer name ID and a string with a name. Any name can be given. Followed by we are writing a student object which includes student ID, then student name. We are utilizing this keyword in order to map this. So this ID will be the ID of the student followed by this name equals name. So once this is done, we are closing the brackets. This gives a simple example for our object output. So which is the object output? So it is none other than the student of. So this is the object output stream that has been created according to our application. Great. Now let's head forward and understand the object input stream. As we know, object input stream is also used to input or read the information or the data from the object, right? In order to do this, we need the package that is none other than Java IO package. Let's see the example for this, that is import java.io. This is the package that is being called. Further, we are creating a class in order to read an object. Okay, read object. Then we are writing a main method along with the throw exception. Done. So we can observe here we are writing object input stream OIS. So what has to be included in this? It has to be defined with a new object that is being created. Thus the name will be new file input stream and the name of the new file that has been created, it is none other than student.dat. As we know, this .dat is a form of binary file that is being created. All right, now let's see that student s equals student of. So this is a class which we are defining to read a object, followed by writing a print statement, that is system.out.println of that student's ID space name. So what it should be? A ID, then followed by a space, followed by student's name has to be written at the output. Then we are closing this file. Okay, close the brackets. Further at the output, we will get the student ID. So one is the ID followed by a simple space here and the name of the student. So in this way, we can go forward with writing the object input stream class. Let's move forward and understand the advantages of file handling. So till now we have studied how to handle the file, that is the file handling occurs through stream. Then we did understood what is a simple stream, then the types of streams. Then we did discuss what is the hierarchy of that stream. Then we did understood each of every file type with a simple examples, right? Now let's understand the advantage of this file handling. The first and the main advantage, what we can say is it is important for permanent data storage. Further, we can also consider that by using file handling, we can easily retrieve the data. The file handling also supports the object storage as well as efficient data processing can be considered as a result of file handling. So this is all about today's session, and in the coming session we will be discussing event handling and the GU interface with respect to the Java programming. So this was all about our first session. Thank you.